Okay, now let's try and look at some examples that use the quotient law for exponents. So I have a couple here. Let's start over here. So we have 3 squared divided by 3 to the negative 1. 3 squared over 3 to the negative 1. So what do I get here? Well, I just take the top exponent and subtract the bottom exponent. I'm going to do that in all cases. So since we have a 3 here and a 3 here, I get a 3 to the 2 minus 1. Well, what's that? 2 minus 1, that's 3 to the 3, which is just 27. Now, this isn't the only way we could have done this. I could have actually just written things out. For example, 3 squared over 3 to the negative 1 is 9 divided by 1/3. And if you divide by a fraction, you multiply by its reciprocal, which gives me 9 times 3 over 1, which is also 27. So that's another way to get the same thing. However, since we're talking about quotients, the quotient rule for exponents, we decided to do it this way first. There's no right, there's no wrong way. Quite often, it really helps to know more than one way of doing something, because if you know how to do something in more than one way, you'll know whether or not you did it right. Because if you get 2 different answers, then obviously one of them is not correct. All the problems here will have a consistent solution. We're not getting philosophical. There's a final outcome. So let's look at this one. X to the negative 2 divided by x to the negative 3. Well, this is going to be x to the minus 2 minus 3. All we do is we subtract the exponents. Because we have the same base, we can follow our rule. And what does this give us? This gives us x minus 2 plus 3, because minus 3 is plus 3. And this gives us x to the 1, which is just x. Very simple. Once again, I could have solved this differently as well. If I have x to the minus 2 divided by x to the minus 3, well, this by definition is this, because we can get rid of the negatives in our exponents if we take the reciprocals. Okay, well, what could we do here? Well, I have a fraction divided by a fraction, so I flip the second fraction and I multiply. 1 over x squared times x cubed over 1, which gives me x cubed over x squared. Well, now I've gotten rid of the negatives. And without using any quotient law of exponents, I can cancel. That leaves me with an x in the top and a 1 in the bottom. Remember, we're dividing by x twice. So when I divide by x the second time here, I don't get a 0 in the bottom. I get a 1 because x divided by x is 1. So I'm left with x over 1, which, lo and behold, is the same as our answer over here. In this case, this was much, much shorter than having to go through all this work. Now, I can think of a few ways to simplify this because we have a bunch of rules now, so there's so many different things that we can do. However, let's not see how many different ways we can do this problem. These are 2 ways of doing it. This was one situation where using our quotient rule for exponents was much, much shorter than this other method. Now let's look at this last one. A little scarier. We have an a, we have 3, we have numbers, and we have exponents together. But this is 3a to the 4th power divided by 3a to the 4th power. The bases are the same, so all I have to do is take 3a to the 4 minus 4, and that gives me 3a to the 0, which is just 1. If we remember, anything to the 0th power is 1. Now, there is one note. technically if a was 0, this would be undefined. So we should leave some note saying, well, for a not equal to 0. But if the problem had told us that a was not 0 in the beginning, then we would have just gotten to 1. So those are some examples using the quotient rule for exponents. And now we're going to move on to our next rule of exponents next.